Chapter 3, Section 5, Factoring difference of two squares and sum or difference of two cubes. So these are going to be your patterns. So if you remember previously, the first thing we talked about was factoring out a greatest common factor. So when you factor, this is going to be the first thing that you always look for. Is there anything in common? The next thing you're going to look at is how many terms do I have? And if you have 4 terms, then you're going to factor by grouping. If you have 2 or 3 terms, then I would look for a pattern. That would be the next step that I would take. So let's look at these patterns. The first one is the difference of two squares. So if you look at these words, it kind of tells you what you're looking for. Difference means subtraction, so you have to have subtraction in between your two terms. If you'll notice down here in red, this does not apply to the sum of two squares. If you see a plus sign in between two squares, that is prime. When anything will not factor, it is called prime. So you have to have the difference, a subtraction sign, and when we say two squares, the difference of two squares, you have to be able to take the square root of the first term and the square root of the second term. And we'll talk about square roots in just a second. So when you see this pattern, immediately the first thing you're going to do is make 2 sets of parentheses. Just open up 2 sets of parentheses. And then what you're going to do is you're going to put a plus in one and a minus in the other, and it does not matter which is which. And then the next thing you're going to do is you're going to take the square root of the first term and put it in the first spots in each parentheses. And then you're going to take the square root of the second term and put it in the second spot in each parentheses. So let's look at this problem right here. First of all, you have to recognize that this is the difference of two perfect squares. So this minus sign tells me that I have the difference. Now, the next thing I'm going to test is, can I take the square root of 4x squared? Well, the square root of 4 is 2, so I can take the square root of that. And the square root of x squared, when you take the square root of a power of an exponent, you have to be able to divide it by 2. So in other words, your power needs to be even in order for it to be a perfect square. So the square root of x squared is just simply x. And then the square root of 25 is going to be 5. So remember your squares and your square roots. We're going to be talking about this in chapter 5 as well, so you definitely need to know your square roots. Your perfect squares are going to be things like 1, 4, 9, 16, 25, 36, 49, anything that you can take the square root of. So for example, the square root of 49 is 7 because 7 times 7 is 49. Square root of 25 is 5 because 5 times 5 is 25. Anything you can multiply times itself, that number is going to be a perfect square. Alright, so to factor this, since I know that I have the difference of two squares, what I'm going to do is I'm going to open up 2 sets of parentheses. And I'm going to put a plus in one and a minus in the other, and again, it does not matter which is which. And then I'm going to take the square root of the first term. So the square root of 4x squared is going to be 2x, and you're going to put it in the first places of each binomial. And then you're going to take the square root of 25, and that's going to be 5, and you're going to multiply, or you're going to put those in the second spots. So remember, previously, when we were multiplying these things out, I told you to pay attention to these patterns. Well, the pattern that we just did, if you remember, is called a sum and difference. And remember, if we had 2x plus 5 times 2x minus 5, remember that was a sum and difference pattern. And when we fold this out, I can fold correctly. If we fold this out, we're going to have 4x squared minus 10x plus 10x minus 25. And those middle two terms cancel each other out because they're zeros, or they're opposites, which goes to 0. And you get that difference of two squares. Well, in this section, we're going backwards to that. And so you're going to factor it. So the patterns are very, very important. Okay, so let's look at all of these. For those of you who came through 098, we talked about the difference of two squares, but we certainly did not do any difference of two squares like this. So let's look at this one. This is the difference of two perfect squares because you have a minus sign and I have even power, so I can take the square root of these two. So the first thing I'm going to do is I'm going to open up two sets of parentheses, plus in one, minus in the other. Now, the square root of x to the fourth, like I said, you just divide your exponent by 2, so that's going to be x squared and x squared, because x to the second times x to the second is x to the fourth. If you add those exponents, you know your exponent rules. And then the square root of y to the fourth is y to the second and y to the second. Now I want to show you something, and the directions on your test, in your homework, whatever, the directions are going to say factor completely. And the reason being is because this answer that we came up with is not factored completely. So let's look at both of these. This one is the sum of two squares, and we said earlier that the sum of two squares is prime, so remember that is going to be prime. Anytime you can't factor something, it's prime. So since the first one is the sum of two squares, we're just going to leave it alone. We're going to bring it down and not do anything with it. But the second one, let's look at that. You have the difference of two squares again. So you have to do this pattern one more time. Open up two sets of parentheses, plus in one, minus in the other. Square root of x squared is x, and the square root of y squared is y. And this is factored completely. And so that's what I want to see on your test, is something factored completely. Okay, the one on the right. This one has a binomial square in it. So this is still the difference of two perfect squares. So when you take the square root of a binomial square, what happens is, watch this, and we'll talk more about this in chapter 5, but the square root symbol has an index of 2, and what happens is when you take the square root of a square, those two cancel out and you're left with that binomial of x plus 2. Or I'm sorry, x plus 3. So this is the difference of two perfect squares. So we're going to open up two sets of parentheses, plus in one, minus in the other. So when I take the square root of x plus 3 quantity squared, you already have seen that you're going to get an x plus 3. And then when you take the square root of y squared, you're going to get a y. So this answer is fine with me. If you look at the answers in the back of the book, they're probably going to put it in descending order, which means they would have something like x plus y plus 3 and then x minus y plus 3. But either way. Okay, the bottom on the left, bottom left. This problem is the difference of two perfect squares, but you have to remember that I told you to always look for the greatest common factor. Now in this particular problem, I can do the pattern, and I'll show you that. I can definitely do the pattern because it is the difference of two squares. The square root of 9x squared is going to be 3x. And the square root of 36 is going to be 6. But I want you to notice something. This is not completely factored, because this group has a 3 in it and this group has a 3 in it. So then you would have to turn around and factor out the 3 of both of these. And then all kinds of craziness. You may think, oh, well, I have a binomial factor that I can factor out, and that's not true because they're not the same. The only thing that you can do here is you can put that 9, the two 3's together, 3 times 3 is 9, and bring it out front. Well, so, yes, this is the difference of two squares, but remember I told you, always look for the greatest common factor. Always look for greatest common factor. And let me show you how much easier it is when you see the greatest common factor. So in this, I know that there is a 9 in common. So if I factor out that 9, I'm going to get 9 times x squared minus 4. Now this is not completely factored. Remember I told you on the test and homework it's going to say completely factored, and this is not completely factored because this is the difference of two squares again. So what I'm going to do is I'm going to do the difference of two squares pattern. So we're going to have a plus and a minus. The square root of x squared is x, and the square root of 4 is 2. So to me, I think that was a lot easier. So I would say always look for something in common first. Alright, so let's go here. This is the difference of two perfect squares as well, and we learned up here how to take the square root of a binomial squared. So we know that these are perfect squares because of these exponents. So let's open up two sets of parentheses, big parentheses, because this is going to be a big problem. Put a plus in one and a minus in the other. Now, the square root of x minus 1 quantity squared is just x minus 1. And then the square root of x plus 4 quantity squared is just x plus 4. Now, the reason I put those in parentheses, whereas I didn't put them in parentheses up here, is up here I didn't have anything that I could put together. But down here, look, I have a binomial plus a binomial, and we have stuff that are in common. So I can say x plus x is going to give me 2x. And I can say negative 1 plus 4 is going to give me plus 3. And over here, same thing. I can subtract x minus x goes to 0. And negative 1 minus 4 is going to be a negative 5. And so that's going to be completely factored. So that's your difference of two squares pattern. And like I said, you can see it as in a problem as easy as something like this, or you can see it written something like this. So just make sure you understand that you're looking at the difference of two perfect squares before you do this pattern. Okay, the next pattern is a sum and difference of two cubes. So that means that, and in this pattern, it doesn't matter if it's plus or minus in between. That's what that symbol means. Is a plus or minus symbol. It doesn't matter if it's positive or negative. But your first term has to be a perfect cube, and your second term has to be a perfect cube. So let's talk about cubes. What are some perfect cubes? Well, 8 is a perfect cube because 2 times 2 times 2 is 8. 125 is a perfect cube because 5 times 5 times 5 is 125. 27 is a perfect cube because 3 times 3 times 3 is 27. So the cube roots of these perfect cubes are the numbers that you're multiplying together to get them. So for example, the cube root of 8 is 2, and the cube root of 125 is 5. The cube root of 27 is 3. And so cube root of 64 is 4. And so we'll just leave that there. Like I said, we will revisit that in chapter 5. So when you recognize that you have the sum or difference of two perfect cubes, what you're going to do is you're going to find the cube root of your first term. So A is going to be the cube root of your first term, and then B, find the cube root of your second term. B is going to be the cube root of your second term. And then you're going to follow the pattern, and here's your pattern. You're going to have A same sign B times A squared opposite sign A times B, always plus B squared, and you have to memorize this. If you don't want to memorize the words, then you can memorize the algebraic formula. A same sign B times A squared opposite sign A times B, always plus B squared. So that's up to you if you want to memorize the words or the pattern, but you have to memorize it. Okay, so the first thing I want to do is I want to take the cube root of each one of these. So notice I'm going to make a binomial times a trinomial. So I'm going to go ahead and set up the parentheses for that. The skeleton is what I call it. A binomial and a trinomial. So in my binomial, it's going to be the cube root of my first term. The cube root of 8x cubed is going to be 2x. And we're going to use the same sign. And the cube root of 125y cubed is going to be 5y. Now, when you're finished taking the cube roots of your original problem, you are done with your original problem. Don't go back to it. So we have A, which is 2x, same sign. We have a plus in our problem, so we have a plus here. B, so we took the cube root of B cubed, and so we have B. Don't go back to your original problem. Times, that's your parentheses next to each other, A squared. That's going to be your 2x now. Don't go back here. It's 2x. So A squared is going to be 4x squared opposite sign, so we're going to use a negative because in our original problem we had a plus. Here is a plus, so we needed the opposite sign. And then a times b, we're going to multiply these two together. So we're going to get 10xy, always plus, and then b squared. So b squared, I'm going to make some more room here. B squared is going to be your 5y squared is going to be 25y squared. So you have to memorize that pattern. A, same sign B, times A squared, opposite sign, A times B, always plus B squared. And if you forget about your signs, or if you get confused about your signs, you can remember SOAP. Same sign comes first, that one goes here. Opposite sign comes next, that one goes here, and always plus goes last. Same, opposite, always plus, SOAP. So that's going to help you remember your signs. The next pattern we're going to talk about is the trinomial squares. So if you'll remember, when we were multiplying, if we had something like x plus 3 quantity squared, remember I asked you to expand it and full it, and then when we fold it, if you remember, we got x squared plus 3x plus 3x plus 9. And what happens is those middle two terms double. So do you remember what we called it? We called it square, double square. Here's your pattern. Trinomial squares. You have a square, double, square. And so this second sign always has to be plus. Always has to be plus. And then the first two signs, it doesn't matter. So how do you know you're looking at the pattern? First of all, you have to have a trinomial. And second of all, you have to have a perfect square at the first one and a perfect square for the last one. And third, that second sign has to be plus. So three things. Number one, of course, you need a trinomial. Number two, first and third terms, first and last terms, have to be perfect squares. And then the last one, last sign, must be positive. Alright, so let's look here. We have a trinomial. The first term, 25x squared, I can take the square root of and get 5x. The last term, I can take the square root of 49 and get 7. And that last sign is plus. So this is going to be my pattern. So what do you do when you have this pattern? Well, what I always do is I open up a set of parentheses and square it. Because a perfect square trinomial will always factor into a binomial squared. You need to remember that. We're going to use that in chapter 6 a lot. So a perfect square trinomial will always factor into a binomial squared. So what I do is I open up a set of parentheses which represents my binomial and I square it. Then what you're going to do is you're going to match that first sign. Second sign doesn't matter, you're just going to match that first sign. And then like I said, the square root of 25x squared is going to be 5x and the square root of 49 is 7, and you're done. So make sure you don't have anything in common before you do this, of course. For example, look here. It's a trinomial, but we can't take the square root of 48 and we can't take the square root of 25. So there has to be something in common. So we need to figure out what's in common here. Trying to get a perfect square, easiest one to me is that 75 would go to 25. So I'm thinking let's factor out a 3. So if I factor out a 3, I'm going to get 16m squared, that looks good, plus 40m plus 25. And remember, your directions are going to say factor completely, so this one is not factored completely. We just factored out the greatest common factor. So when you factor out a greatest common factor, that greatest common factor has to keep on coming down. And then if I look at this trinomial now, I see that it is my pattern. So I'm going to do a binomial squared. The sign is going to be plus. You have to match this sign. Square root of 16m squared is going to be 4m. And the square root of 25 is going to be 5. And now it's completely factored. Alright, so let's look at these three and see if we can identify how we're going to factor this. And the reason I say that is because that's going to be the hardest part on your test. When the directions say factor completely, what you're going to see is just a bunch of polynomials thrown at you. And you have to look at those polynomials and decide which technique am I going to use. So we've talked about three techniques. We've talked about greatest common factor, we've talked about grouping, and we've talked about patterns. So let's look at this one. This one, you're going to look for a greatest common factor, and I see, I think, a 3 and an x. So let's bring out a 3x. And when we do that, we're going to have 4x squared minus 9y squared. And again, the directions are going to say factor completely. This is going to be the difference of two squares, so I can factor again. So I'm going to bring down that greatest common factor. Open up two sets of parentheses, because that is the pattern. When you have a pattern, you have to remember the process. Open up two sets of parentheses, put a plus in one, a minus in the other. Square root of 4x squared is going to be 2x. And the square root of 9y squared is going to be 3y. Now it's completely factored. Always look for the greatest common factor first. Alright, let's look here. This, I can take the cube root of x cubed and get x, and I can take the cube root of 27 and get 3. So this is the difference of two cubes. So once you realize the pattern, you have to remember the process. So I know that I'm going to have a binomial and a trinomial. So the first step is to take the cube root of the first one, which is going to be x, and then match that sign so it's the same sign. And then the cube root of 27, which is going to be 3. And then remember, when you're finished with that problem, you're going to forget about it. So then your next step is going to be square root of the x. So you have x squared, opposite sign, multiply the 3 and the x together and get 3x. Always plus, and take the square or square the 3, which is going to give you 9. So that's your pattern. Okay, this one. This is a perfect square. This is a perfect square, and it's a trinomial, so it's a trinomial square. So what we're going to do is we're going to open up a binomial square and match that first sign. The square root of 16y squared is going to be 4y, and the square root of 49 is going to be 7. And so you have the pattern. So what I would like for you to do is I would like for you to try the factorizations on page 157. If you have any troubles with these problems, bring them into class and we'll work them in class.